In the domain of science and astronomical secrets, the subject of what existed before the enormous detonation has mixed discussions and further intrigued personalities for a really long time. This significant inquiry doesn't simply challenge how we might interpret the universe. It challenges the actual limits of human knowledge. Envision standing at the edge of presence, gazing into the tremendous murkiness, and thinking about what lay there before our universe was conceived. The event of the Big Bang marked the start of time, space, and all that we know. Yet, was there a second prior to this? Could there have been a condition of nothingness, a quiet before the astronomical ensemble began? And, if this is true, was it, or maybe was there, something undeniably more alarming that existed before time itself? As we jump further into this question, science takes us on an excursion past the universe's starting point into ideas that resist our grasp. Physicist Brian Cox, known for his investigation into the marvels of the universe, suggests that something unnerving could have existed before the enormous detonation. He challenges us to reconsider our idea of reality, time, and space. In this investigation, we'll dig into the science, the hypotheses, and the stunning secrets that may make sense of what existed prior to everything. We'll inspect thoughts like universal expansion, quantum changes, dark energy, and even multiverses. The responses we've uncovered may very well stun you, yet they could also open new understandings of our spot in the universe. Prepare to jump deep into a world beyond imagination and science, where the obscure still weaves the shadows, leaving researchers dumbfounded and sometimes even disturbed. Let's explore what existed before the enormous detonation and why these speculations challenge all that we thought we knew. To comprehend what may have existed before the enormous detonation, we first need to painstakingly analyze what the Big Bang really was. The Big Bang, as researchers characterize it, refers to the moment when the universe became incredibly hot and thick, expanding quickly to set off the formation of all matter, energy, and enormous forces. When we gaze toward the night sky, we see proof of this hot start, with galaxies fanning out in all directions from a singular point. However, why did this occur, and was there a time before this thick, hot beginning? According to the hypothesis of universal expansion, there was undoubtedly a preceding, and it was a long way from empty or serene. Astronomical expansion proposes that before the Big Bang, the universe was in a state that was cold, empty, and stretched out, practically like an immense vacuum. Anyway, this vacuum wasn't totally unfilled. It contained an enormous measure of energy that fueled the fast extension of space itself. This development, called expansion, occurred so rapidly that it basically laid the foundation for all that would continue in a part of a subsequent space, extending its speeds incomprehensible until the development slowed and the energy changed into issue particles and the forces we perceive as the Big Bang. However, what was the nature of this energy? Why did it suddenly blow up the universe, and why did it stop? Researchers trust that this universal expansion created patches of the universe, each encountering its own Big Bang. Envision a fabric extending infinitely with small bubbles forming throughout. Each bubble represents a universe, including our own. This idea, called the Inflationary Multiverse, suggests that there are potentially boundless Big Bangs and an infinite number of universes. Our own is only one of many. This mind-boggling reality challenges our comprehension of the actual universe and leaves us with the question, what else is out there? The idea of nothingness before the Big Bang is hypothetical, not real, at least according to our current understanding. Regardless of whether you eliminated all energy, particles, and radiation from the universe, it would still not be truly void. Our universe is filled with dark matter, dark energy, quantum fields, and various forces that make a certain tapestry of something, even in its most empty form. Regardless of whether we imagine stripping away all these forces, leaving a dark emptiness, the universe would still create new forms of energy. This paradox is perplexing to scientists as it suggests that true nothingness may be impossible within our vast understanding. As we test further, we find that space itself has properties, rules, and constants that don't permit it to be totally void. Envision making a region with literally nothing in it. No particles, no radiation, and no energy, except for quantum fields and key constants that still exist. This implies that this nothingness has properties. For example, there's a phenomenon called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still momentarily appear and vanish, creating a spooky resonance of activity, even in what should be empty space. This opposes our idea of a true void and suggests that, indeed, even before the Big Bang, there was something that researchers are only beginning to understand. One of the most bewildering speculations in modern cosmology is the possibility of timeless expansion. If expansion could cause our universe to exist, it's conceivable it could continue endlessly. Brian Cox describes a frighteningly immense inflationary multiverse, where universes are infinitely created and continue expanding. Envision each Big Bang as a spark igniting another universe, while expansion endures in other regions, creating countless other universes. This cycle could, in theory, continue forever. This idea of endless universes gives birth to a captivating concept of a fractal universe, where each new universe has the potential to create its own Big Bang. Every universe exists as a separate, independent domain, unaffected by the others due to the rapid development of space. For scientists, this hypothesis is both exciting and disturbing, as it proposes an infinite multiverse with no ultimate start or end. Imagine our universe as only one speck in a giant astronomical design, growing and creating forever. And what if the startling truth is that there is no before or after, but simply an eternal cycle of universes forming and decaying? Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe isn't simply an assortment of matter floating in space. Rather, it's a network of energy fields that fill the universe, connecting to create all that we observe. These fields are like invisible seas, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still dynamic. Particles can appear and vanish in these fields, gaining energy briefly before returning it. This phenomenon results in virtual particles, substances that momentarily exist and then evaporate, leaving behind a faint memory of their presence. The idea of virtual particles challenges the notion of a true void. Imagine an empty universe where all matter, radiation, and energy are eliminated. Would you have total nothingness? According to quantum field theory, you wouldn't. Even in a vacuum, fields would remain dynamic, occasionally producing transient particles. This constant motion in what should be nothing suggests that the universe doesn't understand our concept of void. Have played a key role in shaping the very nature of the universe as we know it. The idea that dark energy could have influenced the inflationary phase before the Big Bang challenges our understanding of the origins of space, time, and matter itself. If dark energy existed in a more potent form before the Big Bang, it could have propelled the rapid expansion that led to the formation of the universe. As we delve deeper into the mysteries of dark energy, we are forced to confront fundamental questions about the nature of the universe. Was there a time before time? A state of nothingness before the Big Bang? Could dark energy have existed in a form that we cannot yet detect, waiting to trigger the birth of space and time? These questions lead us to contemplate the possibility that the universe, as vast and enigmatic as it is, may not be an isolated entity at all. Instead, it could be part of a much larger, more complex system that spans across multiple dimensions, beyond our current perception. Theories such as the multiverse and eternal inflation suggest that our universe might be just one of many, existing in a never-ending cycle of creation and destruction. This idea raises even more profound questions. What does it mean to exist in such a multiverse? How do we comprehend the scale of existence when it stretches across an infinite number of universes, each with its own Big Bang and its own reality? In exploring these possibilities, we are drawn to the limits of human knowledge. The more we learn, the more we realize how little we truly understand about the fundamental nature of the universe. Concepts like nothingness, dark energy, and the multiverse stretch our imaginations and push the boundaries of science itself. Yet, despite the complexity of these ideas, they offer us a glimpse into a deeper, more profound truth about our place in the cosmos. Ultimately, the questions surrounding what existed before the Big Bang may never be fully answered. However, the pursuit of these answers continues to inspire scientists and philosophers alike, driving us to explore the unknown and challenge the very limits of human understanding. Through this journey, we gain not only new insights into the origins of the universe, but also a deeper appreciation for the mysteries that remain just beyond our grasp. As we continue to explore the universe and its secrets, we may discover that the true nature of reality is far stranger and more intricate than we could ever have imagined. And perhaps, in time, we will find that the answers to these profound questions were always there, waiting for us to uncover them. I have molded the circumstances that prompted the introduction of our universe. Could dark energy be the quiet draftsman of inestimable expansion, or even the genuine beginning of our universe? As we investigate this chance, we defy the capability of dark energy not just as a power molding our universe, but also as a key that could open the insider facts of the multiverse itself. Another hypothesis that offers an option to the Big Bang as the definitive start is cyclic cosmology. In this model, the universe goes through vast patterns of birth, passing, and resurrection. The Big Bang is definitely not a one-time occasion, but may be part of an inestimable cadence where universes grow, break down, and afterward regrow in another cycle. This hypothesis suggests that our universe could have been reawakened from the leftovers of a past universe. The course of compression and development in a cyclic example would actually intend that there was never a genuine start, but rather an endless grouping of universes arising, advancing, and also recharging themselves again and again. Cyclic cosmology raises significant inquiries concerning time, as it suggests that time itself may be round rather than direct. If this hypothesis is right, it could imply that what existed before the Big Bang was essentially one more adaptation of the universe, one that imploded exclusively to bring forth our ongoing universe. For researchers, this hypothesis offers an elegant answer to the subject of an extreme, starting by proposing that there isn't one. Rather, the universe has consistently existed in some structure, rising above our thoughts of time and presence. Early-stage gravitational waves are another entrancing concept that could hold pieces of information to what existed previously the Big Bang. Gravitational waves are swells in space-time brought about by enormous, inestimable occasions, and researchers accept that early-stage waves, if identified, could uncover subtleties of the universe's earliest moments. These waves would be remainders from the inflationary period, conveying information about what occurred during the first part of a second after the Big Bang. But what if there were waves that originated before even the Big Bang? A few speculations suggest that gravitational waves could exist from a pre-Big Bang time, assuming such a period existed. Recognizing these waves could provide direct proof of events or conditions that happened before expansion in the hot, enormous detonation. Anyway, finding early-stage waves from before the Big Bang is a tremendous challenge. Researchers are developing delicate instruments to detect these subtle waves, hoping they will one day uncover a secret layer of inestimable history. Such a discovery would not only provide answers about our universe's early stages, but also about the deeper, inestimable powers that could have ignited its presence. Quantum foam, a concept proposed by physicist John Wheeler, is another hypothesis that hints at the possibility of pre-Big Bang existence. According to quantum mechanics, space isn't truly unfilled, but is filled with constant variations of energy at the smallest scales. This quantum foam suggests that at the smallest sizes of existence, particles can appear and vanish in transient moments, giving rise to temporary air pockets of energy. This thought upholds the vacuum origin hypothesis, which posits that the universe might have arisen out of an enormous quantum variation in the ocean of quantum foam. The vacuum origin hypothesis suggests that what we see as the Big Bang would, in fact, have been one of these energy variations developing until it became the universe. This view redefines the concept of nothingness, suggesting that even in the absence of matter, energy, and conventional space-time, there still exists a powerful reality. If our universe is indeed the result of a variation in quantum foam, then there may be other universes appearing and vanishing within this quantum ocean. This idea extends the multiverse hypothesis and suggests that our universe's existence might be much more standard in the grand plan of enormous phenomena. Quantum tunneling is a phenomenon in quantum mechanics where particles can pass through energy barriers, even when they don't apparently have enough energy to do so. This concept of tunneling is interesting when applied to the universe itself. Some cosmologists suggest that our universe might have tunneled into existence from another aspect or reality. Quantum tunneling would allow energy to break an otherwise unfavorable limit, resulting in a universe arising out of another plane of existence. This hypothesis adds a puzzling layer to what existed before the Big Bang, as it suggests that our universe might have spilled or tunneled into being from a substitute domain. If this hypothesis holds any truth, then our universe could be one of many that form, evolve, and evaporate inside a much larger secret structure. Quantum tunneling suggests that the Big Bang probably wasn't the start, but instead the consequence of a limit being crossed, a moment when our universe arose, blended into the huge unknown. As we investigate these hypotheses, it is clear that our comprehension of the universe's beginnings is limited. However, the Big Bang was once considered a definitive start, the solitary point from which all present sprang. But now, with ideas like inflation, the multiverse, and quantum fields, we see a much more intricate tapestry. Researchers like Brian Cox push us to imagine that something existed before our universe, something sufficiently powerful to ignite the Big Bang and set off the chain of events leading to our reality. The implications of these hypotheses are both exciting and humbling, reminding us that the universe is full of mysteries yet to be unraveled. So, what existed before the Big Bang? While science may one day uncover more answers, for now, we stand at the edge of what we know, looking into the unknown with curiosity, wonder, and a touch of fear. The boundlessness of the universe, its unpredictable plans, and the secrets it holds remind us that our position in the universe is both exceptional and transient. Embracing this mystery is part of what makes us human and drives us to keep exploring. What lies beyond the limits of our knowledge? As we continue to explore the possible outcomes of what existed before the Big Bang, it's essential to consider the role of awareness and the observer in shaping how we might interpret the universe. A few physicists have proposed that the universe, or possibly its basic properties, could be impacted by the presence of conscious observers. This idea is rooted in the well-known observer effect seen in quantum mechanics, where the act of measurement can change the state of a particle. Could the universe's origins and its continuing advancement be tied to some form of consciousness, either human or otherwise? This thought challenges traditional realist views and opens the door to new, more philosophical interpretations of astronomical events. Another area of interest lies in the connection between existence itself and time. Is time a straight movement, or is it something more pliant, capable of bending and collapsing in ways we can't yet understand? The discovery of time loops or closed time-like curves in the fabric of space-time could offer insights into a universe without a definitive start or end. If time is repetitive or nonlinear, it might suggest that the universe's starting point, or the very idea of a start, is a delusion. As we continue to explore the profound questions about the origins of our universe, the nature of time, and the potential existence of other realms or universes, we are confronted with the realization that many of the answers may lie beyond the scope of our current scientific methods and philosophical frameworks. The journey to understanding the true beginning of our universe may require a re-evaluation of the very principles that govern our understanding of existence itself. In this pursuit, we are faced with an intriguing paradox. The more we learn, the more we realize how much we don't know. The universe, with its vastness and complexity, challenges our perceptions, pushing the boundaries of what is possible and what can be comprehended. From the deepest mysteries of quantum mechanics to the largest structures of the cosmos, the universe continues to unfold its secrets, sometimes providing answers that only lead to more questions. Theoretical frameworks like string theory, loop quantum gravity, and the multiverse hypothesis offer glimpses of possible explanations, but none have provided definitive answers. As our technology advances, allowing us to peer deeper into the cosmos and explore the fundamental nature of space, time, and matter, we may eventually uncover clues that help solve the mystery of what came before the Big Bang. These discoveries, however, might also reveal even more profound mysteries, ones that could force us to rethink the very nature of reality itself. The concept of the multiverse, for example, suggests that our universe may be just one of many, each with its own set of physical laws and characteristics. This idea challenges our understanding of what it means to be unique and expands the scope of our inquiry beyond the confines of our observable universe. If the multiverse is real, then the question of what came before the Big Bang may be part of a much larger and more intricate narrative, one that spans across countless universes and dimensions, each with its own history and future. In this context, the study of the origins of the universe may not just be about finding the first cause, but understanding the larger cosmic process of birth, evolution, and decay. The universe may not have a single beginning, but rather an ongoing cycle of creation, destruction, and recreation. In such a framework, the Big Bang may not be the start of everything, but simply the most recent event in an eternal cycle, an ever-repeating cosmic dance. As we continue our search for answers, we must also consider the role of consciousness and observation in shaping our understanding of the universe. Some theories suggest that consciousness itself may be a fundamental aspect of reality, influencing not only how we perceive the universe, but also how the universe itself unfolds. This raises profound questions about the relationship between the observer and the observed, and whether the universe exists independently of our consciousness or if, in some sense, it requires our awareness to bring it into being. These ideas may seem speculative or even fantastical, but they reflect the ongoing evolution of our understanding of the cosmos. As our knowledge expands, so too does our capacity to imagine and explore new possibilities, each one offering a glimpse into the vast unknown. Whether through the study of dark energy, the search for quantum gravitational waves, or the exploration of new theories of space and time, we are embarking on a journey of discovery that may ultimately reshape our understanding of the universe and our place within it. In the end, the question of what came before the Big Bang may not have a definitive answer. Perhaps the true nature of the universe transcends our ability to comprehend it fully, leaving us with only fragments of insight, each piece contributing to a larger, more intricate puzzle. But it is through the pursuit of these questions, the exploration of the unknown, and the willingness to embrace the mystery that we continue to push the boundaries of human knowledge and understanding. And in doing so, we come closer to the ultimate realization that the universe, in all its complexity and wonder, is far more extraordinary than we could ever have imagined.